All right, now we're going to talk about our next step with graphing sine and cosine, and we're going to look and see what happens when we change the period. So remember when you had just your parent graph, y equals sine of x, or y equals cosine of x, the period was 2 pi, or 360 degrees. So what we're going to do today is we're going to change the period. And to change the period, you have to add a coefficient in front of your variable. So one example that we can look at is y equals the cosine of 2x. How does that change? And we're going to look at it on the graph first. I'm going to use our embedded graph from our module. So I'm going to go to my cosine graph. There's cosine. I'm going to add a function. I'm going to say y equals the cosine, and make sure you use parentheses when you're doing the coefficient of x. There we go. That's what happens. And you can notice on here, what happens is the cycle, which used to take 2 pi, which was right here, now took half of that. Took half of that, so it's just pi. And we're going to have a nice little formula to help you remember that. But basically the 2, I'm going to go back to my screen here. This 2 means that it happens twice as fast. So the period of this function is pi, because it happens twice as fast. The normal period was 2 pi. The cosine of 2x, then the period would be pi. If I had y equals the cosine of 4x, it would happen 4 times as fast. And so to get the period, you take your normal period, 2 pi, and you want it to happen 4 times as fast, so you're actually dividing by 4. The period of this is pi over 2. Now let me say that again. If you have cosine of 2x, that means your period is happening twice as fast. So to get the period, you take 2 pi divided by this coefficient. So divided by 2, whatever that coefficient is. So your period is pi. To graphing is about the same. You've got to do a little bit more work with fractions though when you graph. You still start with your 5 critical points. You have 0. But instead of going to 2 pi, my period is only pi. So my ending point is pi. So my beginning, my ending, my middle, which would be pi over 2. And then you got to figure out your quarter mark. So you have a whole pi. So this would be halfway between these two would be pi over 4. So then I have 1 over 4, 2 over 4. This becomes 3 pi over 4. And these are the 5 points that you need to graph. And it's a cosine function. So you know that cosine functions, this cosine function has an amplitude of 1 because there's nothing there. So I start at 1, and then at my next quarter mark I go to 0, and then down to -1, and then I go to 0 and back up to 1. That's how I graph with a different period. I'm still finding 5 points. I'm finding those 5 critical points, but my 5 critical points have changed. Well, let's try one with sine. Our parent graph is y equals sine of x. But I want to try y equals sine of x over 2. So the period of this function is going to be different. The period, you take your normal period, the normal period of the sine graph is 2 pi, and you divide it by the coefficient of x. Well, the coefficient of x here is 1/2. So 2 pi divided by 1/2 is 4 pi. So what that means is because this was a fraction, this coefficient was a fraction, it actually takes twice as long. It basically stretched out your graph. And I'm going to show you what that looks like real quick. If I can find it, I will show you. Oh, I'm on sine. We'll just change this one to sine. Sine of x, and then the sine of 0.5x looks like that. So it's stretched out. Now I'm going to go back and graph it on my screen here. So basically it's going to stretch out the graph. I still need my 5 critical points. So here's 4 pi, and here's 0, the beginning and the end. The middle, halfway, is 2 pi. Quarter would be pi, so 1 pi, 2 pi, this one would be 3 pi. And it's a sine graph. Its amplitude is 1. So you start at 1. No, you don't. I'm lying. You start at 0 because it's a sine graph. And then at your first quarter mark, sine goes up. And then so sine goes 0, up, back down to 0, down to its minimum, and back to 0. It's always going to look the same, and that's why we use those 5 quarter marks to make life easier for you. If you have those 5 marks, your graphs are going to be the same shape. Now, on your assignment for tomorrow, you have to work with a period. So you'll have some problems just like this, and then I'm hoping that you can get to problems where you have like y equals 3 sine of 3 theta plus 1. And remember, theta can be the same as x. And so what you're going to have there is you're going to have an amplitude of 3, a vertical shift of 1, and the period is going to be different. So the period of that is going to be so the period of that is going to be I can't get my screen back. Here we go. The period of this is going to be 2 pi. So the period is going to be our normal period, 2 pi over 3, which is a weird fraction, but it can work. You're going to have an amplitude of 3 and a vertical shift of up 1. So if I graph this, what I like to do is I like to draw it in a couple different sections. The first thing that I'm going to do is put the period as my x-axis. So 2 pi over 3 and 0. And now I know some of you are not good with fractions, but we're going to have to get there. So halfway between 0 and 2 pi over 3 is pi over 3. And then my quarter mark would be halfway between these. Well, half of a third is a sixth, so you get pi over 6. So basically you have 1 over 6, 2 over 6. This one would be 3 over 6, but 3 over 6 simplifies to pi over 2. So you have that. Your amplitude is 3. I'm going to draw in 3 for now. I might have to add more of those in a minute. And so my graph, with just the amp and the period, and it's a sine function, would look like this. I'm going to draw it as a dotted line because I'm not quite done. I still have to now add my vertical shift, which would mean I would move everything up 1. So this point would be here, and up to 4. This one would go up 1. This one comes up 1 to negative 2, and this one goes up to 1. Now this is my actual graph of y equals 3 sine of 3 theta plus 1. So make sure that you, when you do your assignment tomorrow, can get to the point where you're doing a big function like that. See you tomorrow.